Hi, good afternoon, everybody, or good morning, depending on, or even good evening, depending on where you are. Welcome to this day 2 of our series of 2 half-day webinars, building on from the success of the webinars and face-to-face meetings last year for Fusion. Today, we're going to be looking at addressing more the mechanical side of Fusion, which actually may be more familiar to people that are used to working with Inventor. We will be looking at mechanical assemblies and how Fusion is different in how it creates joints compared to Inventor. I'll be going through building some geometry and creating some models, but a lot of what we need to focus on, or what I'd like you to look at are things that are different, or again, to find out the way that Fusion thinks. One of the biggest mistakes people make with Fusion, or really any other new package, is to try and use it in the way that the current system does. So if they're using Inventor, they try and use it like Inventor. SolidWorks, they'll try and use it like SolidWorks. You can force Fusion to work like Inventor. You can force it to work like SolidWorks. But in my mind, you are kind of missing the point in that Fusion does have its own way of working. And once you kind of lock your brain into that way of working, it's a pretty natural tool that's pretty quick and efficient to use. So we'll start out by just taking a quick overview of some of the things that went into creating these learning contents. We'll create a component. We'll look at importing and editing geometry. We will then need to have a short discussion on bodies versus components before we get into assemblies. We'll then have a quick break, because 4 hours is a long time for anybody to be looking at a screen, followed by a quick static stress study. We'll take a look at some of the features there, a quick walk through drawings, and then we'll wrap up the day by doing a bit on CAM inside of Fusion. So some of the things that we looked at around creating content, or the need for an engineer nearing customer, might be other things like the ability to import geometry, to be able to work with geometry from another source, the need for parametric sketching, the ability to apply sketch constraints and work from that point of view. Construction geometry is very strong inside of Fusion 360. And like I said, when we get into assemblies, a lot of people that are used to constraints struggle with the joints tool inside of Fusion 360. Even though joints have been present in Inventor for quite some time, a lot of people have really not quite the hang of it, or it seems a little bit unnatural for them. This is a lot of comments I get from Inventor users that try Fusion and get frustrated with the way Fusion works. With that said, I find myself now struggling to work with constraints in Inventor, as I see how much extra work there is to constrain items. On the simulation side, it is incredibly strong inside of Fusion. In fact, there are some areas where Fusion actually exceeds other tools in the catalogue around simulation. We won't have time to touch on animation today, but we will touch on drawings. So let's start off focusing on mechanical assembly. So today we will be focusing on developing the internal elements, or at least a couple of the internal elements of the assembly of the handheld reciprocating saw that we did yesterday. We will begin by creating a component. Now let's just talk a little bit about the concept of Rule 1. It seems to have, Rule 1 is something that's appeared on the forums a few years back. The idea that you would start off by creating components inside of Fusion before you start building the geometry. You define the components. This is something that I go back and forth on. The reality to my way of thinking is the way Fusion 360 is most valuable is in its flexibility. The idea that you can start by creating right from the outset without pinning yourself into a corner. There are definitely advantages to approaching things from the idea of creating a component, and we'll take a look at this more in depth in a moment. But a key element to keep in mind inside of Fusion 360 is the concept of bodies versus components. Bodies are a collection of features. The thing that you see on the screen in blue, the crank arm, is a body. It is made up of some extrusions, a couple of fillets, maybe a whole feature. So the thing that defines the shape is the body. What makes it able to be joined in an assembly and to have individual part drawings made from it is the fact that it has been defined as a component. Now, what makes that a little bit special is thinking of the context of the timeline. We'll take a look at this, but just to plant the seed, when you look at the timeline of your overall design, now yesterday we did everything all in one space, so we had this very elaborate timeline. In the mechanical environment, when you look at the top level components or the top level in the design, you will see all the features that make up that design, regardless of the number of bodies or components. Now, if you activate a component, and the component was created before creating all of its features, the sketch, the extrusions, the fillets, for example, the timeline will narrow to show those features that are associated with that component. So if you want to more easily navigate the features that belong to a particular part, using a component to create a structure for the part has a huge advantage. If, however, you are quickly just trying to create a design, something that will be static, something that doesn't need to have things sliding around or moving around, then honestly, bodies works just fine. You only really need to go into the components if you're going to start assembling things together. So it really comes down to the user, but it's important in an instruction environment to put the picture together for the students. And I'm sure right now it's a little bit hazy for you, but we'll go through it and you'll understand. And it's a real powerful concept once you get the hang of it, when you come to understand where the properties lie. Other things that we'll be doing in this initial exercise, using multi-loop sketching, being able to reuse a sketch. Any sketch inside of Fusion 360 can not only be used for multiple features, but can be used in multiple bodies or components. So it's all in one place, so you can just reuse it. I really like the way Fusion 360 approaches sketch constraints. I don't think we'll get into custom parameters. And then we will look at press pull, which is a very cool tool. It's multifunctional, and I'll try and show you hopefully at least 3 uses of it. So what we're going to do now, we'll move over into the Fusion. Now, if you didn't manage to pick up yesterday on where all the resources are for this webinar, if you go into the top projects folder where you've got all your individual projects, right down at the very bottom, we've got workshop and events. If I click on that, it opens up, and the one that we're looking at is the adoption path. Yesterday, we're into conceptual design. Today, we're going to look at initially in the mechanical assembly, and then we're going to go into the creating toolpaths later on. So if I click on assemblies, create component, and I'm just going to load up this internal makeup of our reciprocating saw. And hopefully it comes through. Close that data panel. So let's just take a look at the browser quickly. If we go down at the bottom, we have an overall timeline down at the bottom. And you'll actually see here, I've actually got a scroll bar, and you can see all the different things that have happened to create this assembly. We even have a slider bar just to show how to develop this timeline. Much of it is based on using imported geometry. So there's a lot of imported geometry in here. In the browser, if I activate the blade holder assembly, so down here, if I hover, these are all different components. If I go to the blade holder, and you'll notice if I hover over to the right-hand side, I've got a little box. If I just click on that, it activates that component. You will see the timeline only displays now the features that I used to develop this particular shape. And if I go back to the top level of the design and activate it, so back up to the top to activate, click it, you'll see that the whole timeline comes back again. So to create a new component, I have a couple of options available. You can create a component while creating geometry. A bit like yesterday, using an extrude command, a revolve command, you've got the option there to create a new component straight away. I can, in the assembly drop-down, create a new component here, and it tells you would like a new component, or you can go to any component in the browser. Now, if I wanted to on this, if I right-click, I can create a new component. Now, if I did that, that would be a sub-component of that particular assembly, or that component. So what I'm going to do is I'm actually going to make it under this top level. If I right-click, go New Component, you'll see my browser at the side. I've got this new component, and it is active. Everything else is grayed out. If I click once, twice slowly, I can rename this. I'm going to call it Crank Arm. Now I've got Crank Arm there. Even though the rest of the assembly is grayed out, you'll see as I hover over it, my mouse, my cursor, you can reference anything that's in there. So I can pick up on an edge, I can pick up on a face. I have the ability to extract data from anything that resides within this drawing. You can, of course, go over to a component in the browser, so I can actually, in the browser itself, I can pick each one of these and select them from there. And also, if I right-click on any of these, I can actually make them deselectable. So selectable, unselectable. So if I don't want to actually be able to select them, a bit like for Inventor users out there, it's the enable, disable. So I can actually enable and disable components so that they can't be selected in this context. The first thing I'm going to do, if I spin this round now, I'm actually going to create a crank arm between this hole here and the pin that resides there. And the way that it wants to sit, this is actually an arm that comes out, and I want to create a work plane mid between this face here and the underside face. I don't particularly have a face that I can select for that sketch plane, so I'm going to use construction to develop a mid plane. So if I go up to the top, if I go into construct, and if I want mid plane, I can select my top surface of this arm as my first plane. Now to get my second plane, what I want to try and do is select this underside face. And you notice as I'm going across here, it's quite hard to pick that underside face. However, in Fusion, if I hover over this end one, select and hold, I actually get an option. I have a set that I can actually select down here. So I've released my button now. You can see I can actually pick other faces that are close to that one. So I click that one there. It then has created now this mid plane between that top and that bottom face there. And it's created that plane. Now let's start a sketch. So I can OK that. So we're going to actually start a sketch now. I'm going to be doing a circle. And I can pick my work plane, and you see it brings me right onto this work plane. Before I said about picking up geometry from existing stuff, existing parts and components that are on here. So in Sketch itself, down at the bottom, we have a project option, and I'm going to actually project the inside of this hole here and the outside of the pin on that side. And if I just spin it round a little bit, you'll see it's actually projected that sketch onto my work plane. So I go back to my top view and then press OK on that project. Now I'm going to draw a circle. So I go circle, center diameter. Now again, yesterday I showed you the marking menu. What I could do, rather than having to go up here, if I right click, drag it down to sketch, and then go up to around about the 10 o'clock position, I can do center circle. Now that I've projected this geometry, I can pick up on that center, click once, drag, and I'm going to make this around about 20 millimeters. Price, and we've got that fully constrained circle that's picking up on that center point. Now you'll notice is that the shaded circle appears, and what Fusion also does, if you draw an unconstrained circle, the outline color is blue. So if I just was to draw another circle, and I just drew it up here somewhere, you'll notice now it's shaded, obviously, because it's an enclosed area, but the outline of it is blue. Using the sketch palette, I can pick up a constraint, so I can use the equal constraint, and I can say make this circle equal in diameter to that one, and you'll see I now get that circle constraint. I have to press escape to get out of my previous command. Now at the moment it's still blue, because what I've got, I can still move it around, it's not constrained. I can pick up on this point, and I can just, oops, alright, held it for too long, pick up at this point and drag it. If I come to the circle there and release, you'll notice now it's fully constrained. We've got our constraints, and now I've got into the point, and the circle shape, it's gone dark. You'll also notice the projected geometry. The colour of it is like a purple colour. So if I'm on here, the actual projected geometry, the centre, it comes up a purple. So there is a bit of a colour scheme going on within Fusion that gives you an idea of what is happening with each line that you're drawing. Now what I'm going to do, I'm going to connect these 2 points together, and I'm going to use the 2-point rectangle. Again, I could either come up to the top, or in the marking menu, come down and go 2-point rectangle. What I'm going to do with Fusion here, I'm going to actually just pick my first point to be on this circle here. And as I pull and drag it away, I'm just going to click and attach it to that point there. Now you'll notice now it's actually constrained these two. I just escape once to remove now. What you'll notice in Fusion, whilst I'm still in the command, as I'm moving the cursor around, you'll see it's got the rectangle icon, 2-point rectangle. That's just indicating that I'm still in that tool. So I'm still, next thing I'm going to do, if I'm not careful, is draw another rectangle. If I escape once out of that, it keeps me in my sketch environment, but it removes that command that I was using. I can now pick up this and drop it down. You'll notice that this side keeps to the circle, but these don't. If I was just to bring this point here, attach it onto the circle, now it's constrained the rectangle to the actual circle on both sides. So if I pull it up and down, I can adjust that size. And it's built in that symmetry for me. What I'm going to do, I'm going to set the width of this to 10 millimeters. Again, I can either go in the sketch, down to sketch dimension. I could use the D short key, or again, if I right click, sketch, to sketch dimension. And I can just place 2 points, come across, and make that 10 millimeters. Because it's got symmetry in, it's just automatic for me. And it goes black because it's now fully constrained. One of the things I can do, again, you'll see I'm still in the dimension. Press escape. I can here just change some of these lines to construction if I want to do. So just press construct, click on the line, press construct, and it changes it. Click on the line, press construct. It gives me a blue pattern there. If I look at this now in 3 dimensionals, you see how it's all connected up. I'm going to now stop sketch. Now one of the commands that we're going to use today is the press pull. I can either put it into modify press pull, use a shortcut key Q, or if I right click, I've got press pull just there. Now at the moment it's just saying press pull on the dialog box. If I was to hover over this circle and select it, you'll see automatically it changed to extrude. You can also use it to move faces or resize faces. It's actually a multifunctional tool, so it's pretty great for direct modeling. But it can also create features inside of parametric model, and you can apply fillets with this same tool. So we've grabbed this circle sketch, and what we can do is we can start to drag it up. You'll notice that we've got the same icons that we have with extrude before. We can start from the profile plane, we can offset it a little bit, or start from an object. We can go from one direction. We can have two sides where we can change one side and the other, or we can be symmetrical. This one we're going to be symmetrical. We can either, the measurement that we put in here, can either just be half of it, or it can be the full length. I want to make sure it's the full length. And the distance that I'm going to put in here is 13 millimeters. I could have put a taper angle in if I wanted to. And you can see there, I can put a new body or a new component. We're already creating a new component, so I'm just going to leave it at new body and press OK. Now, as usual, when a sketch is used for a feature, its visibility is turned off. So you see now that sketch is gone. But by going into the browser, so the browser for this crank arm, if I open it up, you'll see I've got sketches. If I open up my sketch, you'll see that the light bulb is out at the minute for that sketch. If I click on it, the light bulb turns back on again, and now you can see my sketch, and I can select it. So all I'm going to do, now you'll notice the last command that I used is the top command in the marking menu. So I've right clicked, repeat, press pull. I'm now going to select this circle on this side. Again, I can pull it up, profile plane, it's gone to extrude. This time I'm going to actually do it two-sided. So you'll notice I've actually got two arrows now. I can select one up and one down. This is because we've got a clip on the top with this pin to stop this coming off, this crank arm. And we've also got a boss down at the bottom that we want to make sure that we avoid. So the distances that we need to do is I'm going to pull it down 3 millimeters. And I'm actually going to pull it in a distance going upwards of 4 millimeters, wrong way around, 3 millimeters and 4 millimeters going up. So you see we've got a little bit of clearance there, and we've got a bit of clearance on the boss. Now the operation here is asking for a new, it's initially coming up with a new body. What I can do, I can actually change this to join. Now even though they're not touching at the moment, because they are the same component we're working on, it will actually relate them both together. So if I press OK there, you'll notice the sketch still stays on that we've got. For the middle, what I'm going to do, I'm going to extrude. Rather than use the press pull, I may as well just use extrude. Now I could go up to create extrude or use it from the top there, or I can just use the shortcut key E to extrude. Select the profile, and then as we're working down there, we will extrude it. Just let it check on my dimension, 6 millimeters symmetrically. So I'm going to do symmetrically, both sides, whole distance there, 6 millimeters. And again, you'll notice it automatically went to join because the feature or the sketch overlaps some existing features, bodies that we've got in here. So it's automatically took that as a join command. Press OK. You'll see now we've got that there. The key here is that with traditional parametric tools, where you ask you to declare things ahead of time, that this shall be a new component or this is going to be a new part, Fusion is different. It allows you to modify that structure. If for this arm I wanted to make it a welded part from 3 components, so this boss at the end, boss at this end, and the bar between them in the middle, I can come down to the timeline and modify each part feature to be a new component. So each one of these extrudes that I created there, if I want to go back and edit it here, so for the second one there, if I double click, I can actually go back into it and I can put new body. And that will automatically create a new body. And again, I can go into the crank arm. If I want to change the size, Want to change the distance, just double click it, dialog box. I can just change that to 8 for whatever I want to do. Change it from a join to a new body. And it does it automatically for me. So it is really a real flexible way of working. Now what I'm going to do is turn off the sketch. So if I go back into the menu, turn off the sketch, and it's gone from it. I can just close that, collapse that down a bit for my crank arm. This is where now we can use our press pull tool again. If I right click, go to press pull, it's asking me again, press pull. It doesn't know yet what type of press pull operation it's going to do. Selection, what I'm going to do is select this edge there. Now you'll notice straight away it goes to fillet, because Fusion, when it's seen an edge there, the type of edge it is, it automatically thinks it's going to be a fillet. Click again, the bottom face, and again I've got a manipulator arm, so I can actually pull this out if I wanted to. There. I've got a dialog box, so I can change that to 3mm if I want to do that. Again, on this side here, I can change it. So we've got our standard fillet operations that come in there. So okay. So we spin that round. Now we were looking into this little bit here on this side. This time I'm going to select these 3 faces there, or sorry, edges. So again, I'm going to start the press pull tool. I'm going to select that edge, and if I hover around here, I can actually pick that edge as well. If I start pulling this out, and again, I can modify, and I'm going to actually put that at 3.5. So you can do a lot of functions with this. From a first-person user standpoint, it's really handy for helping someone who is new to solid modeling, who is probably going to be apprehensive with what they're trying to do. Being able to walk them through a simple exercise, we can be able to use the same tools to develop some really cool shape. It's a nice way to introduce people to these concepts. It's a great way to break the ice and get them into being successful early on in solid modeling, without having to worry about the finer points of structure and creating a bunch of different sketches and doing all that sort of crazy thing. I think really using this is a really nice approach. Let me do just a couple of other things here. First of all, I'm going to go to sketch, and I think what we're going to do is we'll put a little bit of a point on here. So let me just turn this around a little bit here. If I go to sketch, slot, center to center slot, I'm going to pick on this face here. So again, I can just pick the face. Now if I hover over the center, you'll see it picks up the center, and I can just get the dotted line, and I can actually pull this and get hold of it. So just my mouse line, there we go, and pull it across. You'll get the dotted line, and I can actually just pull, click once, make sure I don't select anything there, click twice, and pull it up and create a slot. Now it's gone blue, so it's not constrained. You'll notice I've still got the slot symbol at the side of my cursor, so I need to press escape to get out of that. Right clicking, I can go now to sketch dimension. And what I want to do is put a dimension here from the center to center, pull it up. And if we make that, say, 17 millimeters, it moves across that center. And then we do the same. Right click from that point to this center here, and make that one, say, 16 millimeters. Pulls it out, and finally, if I click the outside of this, pull it down, I can make that 1.5 millimeters. There. Now, one thing that I have noticed while I've been doing this, if I'm hovering around on like this assembling and components, and I want to then do you notice how it's selecting stuff here. If I was to right click and do, see already it's selected that, press pull, it'll think I'm trying to do it with that part there. So what I need to do is either hover over the the feature that I want to do press pull with, or if I just come off the model, right click, press pull, then I go into the selection type. As you can see there, automatically it's picked up extrude. I've got my manipulation handles. I can start pulling it down. And for this one, let's just call it a, I don't know, -1 millimeter, something like that. No, 1 millimeter. Let's do -1. We want a cut automatically, and okay. And we've now got this cut in there, which again is pretty cool and pretty easy to do. Looking at some of the other tools, we're going to create. We've got a mirror. Again, that little icon at the side, if we didn't see it, hover over it, you can add it to the top toolbar if you want to do. Click mirror. Now, one thing you may come up with, I was playing with this earlier on today, so that's why it came up with my last type of pattern type selection. If I'm in faces here, I could go around and select all these particular faces to mirror. But this is a feature. If I click features, you'll notice if I'm hovering over my model itself, I can't pick that feature. However, if I go down into the timeline at the bottom, this is where I've got my extrude feature. If I click on that extrude feature, it actually selects it. The mirror plane, select the mirror plane. I want the midpoint of my crank arm. If I just open it up, and in construction, you'll see I've got that plane that I created. I can turn it on if I want, but I can just select it from there. Press OK, and we should now have another slot underneath. There we go. So again, pretty easy. Allow you to do, and select these faces. Now, the next thing that I'm going to do, I'm going to add some text in this slot. We go into the sketch, and we go to text. We can select the inside of the slot there. Zoom in. You'll notice at this stage there's not much choice in how I can locate it. I've got this. If I was to, I've just got this cursor that's coming up. So if I just click, specify the point for it, I can change the angle. I can type the text there. So if I'm just going to type crank arm, see it comes upside down. I can change the angle of it there. Spin it round, -180. I need to change the size of it. So if I make it say 2 millimeters, I can move it and position it. I've got textiles. I can make it bold if I want to do. There's a whole array of fonts that I can pick up. We do have access to a huge font library in there. So once I'm happy with its position, I can then press OK. Right click off it, press pull, select the text, and again you can actually emboss, or you can put it on the outside, internal outside. So I'm just going to pull this out, and I'm going to bring it a distance of say 0.5 millimeters, join. Okay, so very quickly there, I've now got this crank arm, a bit of text inside, and it's pretty fancy. It's not too bad, and I've not really had to use too many tools to actually create this. A bit of a sketch, and using push and pull as the main tool of use, I've managed to create something that's starting to look a little bit like a fairly decent crank arm. Now, what we can also do, we can also leverage other sketches. What I want to do is I want to make a cutout now in this end for this. There's an arm that goes through it. So what I want to do there is I want to lever this profile of this sketch around here. So what I'm going to do is create a new sketch. So create sketch. And hopefully I can pick that face there. So I click that face. One of the things we can do in Fusion is bit like Inventor, where you can actually slice on the sketching plane. It comes up in our sketch palette, and we've got an option here to slice. If I click slice there, it will actually slice through my model on my sketch plane. So now I can actually see the arm that I need to make the cutout for. I'm going to right click and sketch project geometry. Again, I could actually go to sketch project geometry this way. I'm going to go that. What geometry do I want to select? So I'm going to project that bit, and then that bit. Okay. If I go sketch now, and what I'm going to do is I'm going to do a little offset. I'm going to offset these sketches that I've just done. Now you will notice if I hover over this arm, it picks up the full arm to offset. If I hover over it again, hold the left mouse button for a minute, you'll see I get this chain. So I actually have an option of what chain I want to pick up from there. So the first one is the whole arm. The second one is just the bit that we want. So if I select that, and I'm going to leave that at 1. Okay. And then using the L command for line, I'm just going to join up these at the end to make it a complete profile. Just like before, I'm going to now right click, press and pull. Now you notice because I did that during whilst I still had the slice on, it's kept my model slice. So if I just cancel out of that, turn the either stop sketch, we'll remove that, or I could just take the slice off and it would remove it. Right click, press pull. I can now select pieces. There we go. Where is it? There. And that part there. And you'll see we're now into our extrude again. Now one thing you will notice as I'm extruding there, it will actually cut through the case. So if I was to go symmetrical on both sides, you'll notice it's actually started cutting through other components. So I pull that out so it goes all the way through. And I don't want that. What I can do here down at the bottom, we've got an option for objects to cut. And if I open this out, you'll see if I can remove the tick from the gear housing and from the reciprocating arm there, the casing, and it will only now cut through the actual crank arm. If I go OK, it's now got this. There we go. You will notice if I focus in on this front view down here that there is a little bit of collision between this arm and the end there. We could actually just use the press pull tool again, and if I was to just select that face, I can just remove and pull that face a little bit further down. Okay, and if I wanted to now, using the press pull tool again, I could actually add some fillets on if I wanted to do on the sides here, and press pull again. I can actually put some internal fillets in here if I wanted to. So it's quite a nice little tool for doing things like that. So if I just zoom out a little bit and spin that round, so again, quite easy, quite a nice tool to use. Whilst we're in just this environment now, we've just created this component. What I want to do is just have a quick look at physical materials. Yesterday we looked at appearances and overrides, being able to change the colour of the model. Today I want to talk a little bit about physical material. So what we can do, I can actually right click, I can get physical material there and appearances there, or by going into the actual component itself at this corner, right clicking, I can go physical material. Again, it looks very similar to the appearances box we looked at yesterday. You've got the ability to change and look at different libraries. So you can have your favorites library or non-linear non-linear material library. We've got ceramics, you know, if we go into metal, you know, we've got lots and lots and lots of aluminium before we get into the copper and other bits. What we can do, if we wanted to change, if we wanted to make this into now, say, an aluminium, just go back up again, so just into aluminium and drag and drop. It's now changed the appearance to match the aluminium appearance. It's changed the colours, and it's actually put the material up into this in this design. And if I wanted to change anything, if I double click on this box, sorry, I might have to just move it over again. Double click on this box, I can actually change like the density, get into more information about the material itself. So I can change the colour and physical appearance of it. It may or may not change the appearance much, but we have the ability to make these modifications. You can actually copy the materials as well and create your own library. Some of the materials are non-linear, so when you get to stress analysis, or when we get to stress analysis, depending on the material, it will allow for a different type of analysis. Some of them may not be downloaded, so you may have to download. So again, if you're scrolling down in the library, you would get is a little arrow at the side, a little down arrow with an underscore line, and that would indicate that it would need to be downloaded. And it's just a quick, simple click, and it will actually download for you. So that's really just materials. And one of the things that you may get if you're ever doing the ACU exam is, whilst a lot of the questions on the exam need you to measure something, whether it be the volume, whether it be the mass, whether it be an area. If it's an area or a distance, you can use the inspect tool, measure, and you can actually just highlight something like that, and it will give you the loop length of that sketch, the area of that particular surface that you've got there. If I come into the actual arm itself and right click, if I then go into properties, so depending on the material, we've got the area, we've got the density, because we said it's this aluminium, so it's picked up the density from there, and it gives us a mass and a volume. It tells us the physical material that we're using. And there's lots of other stuff there, centers of gravities and information that you can pick up. So if you're ever actually doing the exam, what it wants you to do is actually type some information, usually out of the properties box or from the inspect. So that's just a little hint there when it's looking at stuff. So just cancel out of that. Moving on a little bit, that's what we've just done and created. So it is on this PowerPoint, or a lot of it's in the PowerPoint. So this will be made available to you. We've done the demonstration. The next thing we're going to look at is importing and editing existing components. This is working from existing geometry. One of the things that Fusion has the ability to do is to pull data in from just about any other CAD system. Any translation, or say a SolidWorks part, CATIA part, or Creo part, is done in the cloud through the upload function. So the same process that you might use to go into a project, click the upload button and pull in an existing Fusion file can be used to pull in data from other sources. Some of the standard formats, STEP, IGES, etc., can be pulled directly in by saying create a new design from file. And I'll use that process as well. Once the set data is put in, if it can be automatically stitched into a solid, or in the case of say a STEP file, where it probably already is a solid, you have the ability to go ahead and just do direct modeling and make modifications to that geometry. You also have the ability to turn on design history, so modifications made to that model can be tracked and also edited. So let's take a few minutes and walk through the process. So what we're going to do, I'm now going to actually open up an existing design. So if I go into a few back to, hopefully it's come up on the screen. I don't need that one anymore. I don't know, I might just keep that open. You may use that later on. So back into data panel. Now, if you remember from yesterday, the data panel, try not to use that backup one there. If you use that, that actually leaves the the whole project that you're in and goes to the top level projects. By hovering over the one arrow there, you can go back to the various different folders in the previous set there. So we've got importing, and we've got a nice little imported design here. So I open this. So we have the file here that you can edit. But to show this technique, I have an IGES file that I have saved on my hard drive. So what I've done, I've uploaded this up. But what I can do is if I go File, New Design from File, and what I've got in my hard drive, I've got importing, and it is an IGES file you can see there. So I'm going to open it there. So this should now, he says, it's opened this untitled one, which is exactly the same file, but what I've done, I've actually imported this one from my hard drive. And you can see it actually opened it pretty quickly, and you see it's been able to stitch it into this solid model. Yeah, if I wanted to check it was solid, you know, if I go into inspect and go into section analysis, pick up on a face, there you can actually see it has actually brought it through as a solid. I can spin that around. So you can see there we've actually got a solid model from that IGES folder. It's a very quick and easy way to actually check that. I'm taking a look at the body. There's a lots of different things that probably need to be tweaked on it. So if we actually look here, let's spin this round a little bit. There. We've got a couple of ribs there. So if I'm actually looking at, you know, these particular ribs here, they might not be needed. I may decide that I want to actually get rid of them. So if I select this face, now depending on how I select this, I might get different results coming from it. So if I was to select this face here and just press delete, you'll notice that the whole rib has gone and the whole side has gone, which I didn't really want. If I click on this particular face here and press delete, you'll notice now it's actually deleted a certain feature, but it's actually gone all the way across. And if I was actually to spin it around just a touch and come on to this face here and now press delete, it just actually removes that particular feature, which is what I wanted. Now the thing is as well, if I actually try to do the same on this side, which would be just to delete that face and press delete, it's actually done it. So that's actually pretty good. So what I've just quickly done now, I've just quickly modified that particular part of the model. Again, you can always undo if you've done that. Now, one thing I am actually doing now, you'll notice I've got no timeline in here. I can at any time right click up here and capture design history and turn it on. So I've now actually got a timeline there picking up my base feature. I could have possibly undone them bits that I've just done, but that'll be fine for what I'm doing or need to do on this. Other things that we can do, again, if I now move to, let's have a look, somewhere on here where we can do something. Let's spin it around a little bit. There we go. This particular feature here. Yeah, maybe it's not the result I wanted. So we can play and have a bit of an experiment. So if I click that and press delete, you'll notice it goes sharp. Same on this side. Click, press delete, it goes sharp. So I'm actually now modifying this existing model. If I was to right click, press pull, click on that edge, you'll notice I can actually change the size of that now, and it's actually putting it in as a fillet. I'm not so sure if it would have recognized it as a fillet initially, but now that I've deleted it, I'm putting it in a fillet. So it's actually making it tangential as well, because as I'm doing it, it's making sure that that is a tangential fillet to that side. So I could actually make that say, let's have a see what it looks like at 20 millimeters. It's a nice smooth curve. Yeah. Press OK on that, spin it around slightly, and then pick the same edge. Oops. Right click, press pull, same edge, and again I'm doing the same. So I'm being able to modify this edges file, make it more to what I want it to be able to do. If I then look and I say want to move now to the front of this, so let's come along there. Let's zoom into the front here. Yeah, so hopefully this is a lot of this is pardon me, is getting a feel for the actual tool itself and how it works. If I move to the front end of the model, I want to get rid of this notch in this face, this little notch here. If I click the face and press delete, so if I was just to click that face and press delete, you'll notice it actually deletes the whole thing, which I didn't want. Yep. I'll lose all that, a lot of geometry. Selecting the little face, so if I was to come here and just select that little face there, if I can pick up on it there, and press delete, I didn't like that. Let's try again. Select, come here, we should be able to select that and press delete. Oh, delete 3 faces more. Didn't like that. Let's undo, undo. If I actually, that's what it is, it doesn't like it because it doesn't know what it wants to do, but if I select possibly that face and press delete, there you go, that's what we wanted. So again, it's one of these, it's a bit of experimentation, trying different things, and say it didn't work just by pressing one face or the other face, but by actually pressing both. What it's done is actually give us now and got rid of that notch. We can also change selection options. For this, I'm going to use the move copy tool. What I'm actually going to do now, looking at this, is I'm going to try and make some modifications here. For this, I'm going to use the move copy tool. So if I was to right click and go move copy, and what I want to do, I'm actually going to do some modifications on here. I could here, if I wanted to, I can select bodies. So at the minute, if I was to hover over this, I'd be selecting the whole body. Yeah, it allows me here to select components, faces, and sketch objects. So if you have sketch elements you want to move around, you can use this same tool. For this, I'm just going to use faces. So I'm going to change it to faces. And for this, I'll use the window select to select the actual cylinder faces and the 2 faces that are connecting to it. So I'm going to just spin this around a little bit, and hopefully I'm just going to window select that. And then using the manipulators, I'm just going to move it down 3 millimeters. So if I spin it around so you can actually see what's happening here, if I just pull that, you'll see I'm actually being able to move it down. I could move it across like yesterday when we were doing the sculpting. It's the same manipulators. I can spin it round. I can do all them types of modifications here. So if I wanted to spin it, I'll do it anyway. There you go. I can actually spin and modify that round. I'm not going to do that, but I'm going to move that down a little bit. If I press OK, yep, it's made that quick and simple modification to it. Again, with very little effort, and Fusion's done it all for me. Now, if I want to do something a little bit more drastic, I'm going to use the move copy. Now, I could again, if I wanted to move copy, I can find it M shortcut, or I can find it in the toolbar, in the modifier toolbar, or because it was the last command I used, right click, and it's just at the top. This time, I'm going to select a few more of these faces. I'm going to select this face and this face, and let's see if I can spin this round a little bit and select that face as well there. So I'm selecting a little bit more this time. Now, one of the things that I can do is I can actually set the pivot point of this. So up here, if I go into pivot point, I can actually now select where I want to move this from. So if you'll notice if I hover over a side, then I've got different icons that come up. So I've got a triangle, which is the notifying me the midpoint of a line. I've got a circle, which is the end point. I've got a square, which is the center of the shape. I'm just going to pick on, say, that point there. Now, one thing I need to do once I've set a new pivot point is to actually come back up and say done. So that's my new pivot point. And then using this, I can actually change and modify it. Now, you'll notice that one of the things I haven't selected there. So let me go back into my selection and pick, oh no, let's go back. Let's go take that back to 0, because what I want to do is I want to select that other bit. So put that to 0. Let's go that. What I want to do is select them, that, and hopefully spin it round. Select that one. Yeah, set my pivot point to that point, tick it, and then what I can do here is, there we go, move it and spin it round. Yeah, and so let's put that as minus 22 degrees. Minus 22 degrees. Press OK. And you can see quite a drastic change now in our model. But it's been actually pretty problem-free, pretty simple to do. And it's a lot more complex than just sliding a few faces around or deleting a fillet or two. But it is pretty simple. Then moving on, let's have a look at another part of this model. So let's have a see now. Let's spin this round. So maybe here's something that we can do here. We have a couple of ribs that are missing an opportunity to add some reinforcement around this particular hole, so that these ribs have come to this rather than actually trying to come near this hole to give it a bit more reinforcement. So if I start the move copy again, start repeat move copy. What I want to do, I want to select the pivot point to be the radius center. So what I want to do is make a pivot point there. So I'm going to just zoom in here, set the pivot point, and I want the pivot point to be, let's have a see if I can pick this up. There you go, I think that's picked it up there. Yeah, so it's picked up that pivot point. And tick that. Or maybe I need to select the inside face first. That's what I've done wrong. So again, just X that. Always something. Pick that inside face. Hold on. Cancel that. Start it again. Repeat move. Faces. Select that particular face. Select the pivot point. Pivot point wants to be that center of that, and then hopefully I might need to click done. Now you see it moves that, but not the outer. So what I must need to do is select that outer face as well. And there you go. So we can actually quickly just modify and move that around. So we've got that one. And press OK. So you can see now how quickly that was to modify and change. We could actually look at doing exactly the same on this one. So right click, repeat move, that face, and say that face. We want to set the pivot point to be around about the middle of there. Oh, there we go. That bit. Click the tick, and hopefully we can move it. Yeah. And I think the distance was around about 6 that we put in there before. So I change that, put -6. So we've got around about way of modifying and changing. Again, dead quick way of doing it. There's a lot of opportunities to be able to load in, some really old models that, you've got back, say, from years ago, and modify them and save them and move on. So one of the last things that I want to show just on this model, if I was just to slip and come to the actual front of the model, spin it around a little bit, sorry about this, to there, and if I was to select that front face, I use the press pull. Again, we can actually just press pull that, backwards and forwards in there. So again, you can use the press pull on any of the features. But what we can also do, right click, move and copy. If I was to select this front face, you see all these selection points that come up. When I talked about moving the actual pivot point, if I was just to come up to this top surface there and select that surface using that point, that becomes my pivot point. So I can now just modify and change the angle there around that pivot point. So again, it's pretty easy, and it's a pretty quick and cool sort of option to be able to use. You can simply just grab it, move it. It's just another way of looking at, working with it from there. I can actually just, if I didn't want to, I could pull it from there using that move and copy tool. I can do planar, but because of the particular type of geometry, you can see what's happening. If I'm not careful, I'm filling in that hole. So different pickups, that's not doing anything to it. It's one of these, you play about with it and see how it affects the actual model itself. You see that it's pretty good for using the the rotating in certain directions. They can do, and you can get a very quick and complicated model and design easily and rapidly. So that's really just importing and editing existing geometry. So there you go. This is all in the PowerPoint as well. So it gives you an idea of what you can do and what you can't do. If we then go on to the next little bit, which is really, it's about bodies versus components. And this bit now should take us up to we've got about 5-minute discussion, and then about a half an hour more showing a little bit on joints and assemblies, and then we'll have a little bit of a break. So what I'm going to do, I'm going to start a new design, a quick sketch. So if I go back now to this, all I'm going to do is start a new design from scratch. Yeah, I'm going to start a quick sketch. I'm going to just go a rectangle there. And I'm just going to extrude that a certain distance. Yep. By default, this comes up as a new body. If I press OK, yeah. If you take a look in the timeline browser, I've now got that initial sketch, and I've got that extrusion that I've done. Maybe add a few more fillets, so if I wanted to modify fillet, just add a fillet in there, a few edges. If I wanted to, you can window select as well, so you can actually pick the whole object. Sorry, because I've just deselected them, and you can, add the fillets, press OK, and it's add that fillet to that timeline. You can see this feature has now been added to the timeline at the top level of this component. This is because I've done these actions in this component. It's very important to think about this top level is not necessarily being an assembly, but as a component. So it's able to do things like create drawings from the features and bodies that have been created. You can see my body in the folder. You can turn it on or off. So in the folder here, the bodies, turn the body on or off. If I now want to start building an assembly or something I would think of as an assembly, and I wish I had really created a subcomponent to the design of this box, you can still do that. There are a few different techniques, some a bit more elaborate than others, but this is a fairly straightforward operation. If I right click on the top level, I can select add component. So here I can add a new component, there, and it creates a new component in there. I can name that component if I want. So if I wanted to name this as say box, name it as box. You'll notice now at the moment there is nothing in there. Now what I can do here is I can actually drag in this box here stuff that I've done before. So I can actually drag, if I can get it, let's go into bodies. I can actually drag this body and throw it in there. And it's gone. It's now in the box. The bodies is in the box. In front of the body's there. Yeah, let's see how we sketch. I think sketch box. There you go. And I've got sketches in there now. So all that original design features that I did, I've now managed to put into this box. So everything now is related to the box there. If I add another component, so if I now go now and add a new component, and I call it component 2, I'll leave it as it is. You'll notice now that's now active. If I was to do any sketching here now, so say this time I'll do a circle, I'll sketch a circle, stop sketching and just extrude that circle. Not too bothered at the minute. There. Okay. That now body for this has been added to this component. And the only thing that I'm seeing in my timeline down at the bottom is this component. If I was to go back to my box, activate my box, you'll notice this has now gone to just the box feature. If I go all the way up to the top and activate all of it, I get everything being shown. So each one of these is its own separate feature. So if you're in a hurry and you say we need components to do joints, do drawings and stuff, if I've been in a hurry and I've just done a concept design just using bodies, I can go back and I can create component from the features. I can create it from the bodies, can always move and add them and create what I need, the bodies and the features and the sketches for a particular component, and move it around in the folders to correspond to what I really needed. So you can always go back. It's flexible the way that you do it. If you're in a hurry and forget about rule 1 and forget to create components at the beginning, you can go back later and tidy up your design. If you're creating a design that does not have joints and everything is stuck in place, maybe a jewelry box with some feature panels just stuck to it, you might find that just using bodies is fine for your design. If it's got moving joints, then you need to use components. That's the thing. If it's moving, you've got to use components. If it's not moving and it's just static and it's just been a visual design, visual concept, you possibly don't need components. If you want drawings or separate individual parts, then you need components. So depending on what your students are after, there are a number of options available to them. Going back to the previous model, one thing that I don't think we covered anywhere else is this shortened adoption course is adding a thread to a component. So if I, very quickly on here, adding a thread. If we go over to the hole in this component here, so we go to this part and we go create thread there, it will automatically pick up the nearest closest standard size to it. We can modify the thread with the drop down boxes, but what is really interesting for those of you doing additive manufacturing or 3D printing, this currently is a nice looking thread. Yeah, if you look at that, it looks like a nice thread. Yeah, if I went OK, it looks visually nice. And if I wanted to do, I could click on this and I could go create, and I could create a thread on the top part. That might not have to be full length. Maybe I only want it part length, so I could put something on it. Go OK, and visually, looking at that, it looks okay, but it is only currently visual. However, if you're into 3D manufacturing, additive manufacturing, 3D printing, the problem is when you go to print it, it's only visual, so you won't end up with a thread. But one of the things that is optional in that thread tool, so if I went back to this, the outside one, here is to actually go modeled. And what this model will do actually then, if I press OK, it will actually give me a physical thread model there. So having this option for 3D printing is essential. Because we want some clearance in the thread with the expansion and contraction with 3D printing process, you can actually, using the press pull tool, pick up on one side of the thread face and pull it slightly. So what you can actually do, if I press pull, I can actually come in here, pick up on one side, and if I zoom in, I can actually just pull in just a touch to the 0.01 of a millimeter. Okay, and that's now actually given me a bit of clearance on my thread. So there's a lot of things that you can actually, are cool within Fusion that you can do. Is what we're going to do. We're going to go to assemblies and joints, and to be honest, it's a real nice exercise, and I really like the data sets for understanding assemblies and joints. But before we do that, there's a couple of things to think about when it comes to assemblies and joints. So we'll move just quickly back. Here we go. Make sure we're in the right one, so go back one. The first thing is that you need to have components to be able to apply joints to them, but joints themselves are a different creature. I don't know how many of you have tried, those that are experienced in Inventor and have tried using joints in Inventor. If you did and it seems just a little awkward or off, there is something really important about joints in Fusion and Fusion 360 to think of compared to constraints. When applying an assembly constraint, you are working from a position of the assumption that all degrees of freedom are available. So when you're in Inventor and you're actually starting to put constraints in, what you're doing is actually removing the degrees of freedom. So you apply a make constraint, which removes the freedom of the parts to move apart from each other. You then might add a flush constraint to align it to a side, and then another flush constraint to align it to another side, etc., etc., until you have removed all the degrees of freedom on the two parts, so that they're in position and they move exactly like you want. The way joints works, or the way the joints look at things, is that the assumption that you will be removing all the degrees of freedom at once, and then we'll come back, and based on the type of joint you select, you will be telling it what degrees of freedom you would like to release. So it seems a bit subtle, but in application you'll find that you need to apply fewer of these controls, and they are just smarter. Another thing that is different is the ability to select the geometry. Make your options or your choices known, then define what type of joint will be placed. So I'll show you a couple of examples. We'll go through the one exercise, but I also want to show you a couple of quick examples too. Then there is the case of something called as built joints. I mentioned before that if you have a design, say like the jewelry box that I referred to earlier, you've got the lid, you have the body, and then later down the line you want to show people how the lid pivots. You can of course convert these bodies to components, so at any time you can go back into Fusion, and if initially it was just being a static image, but now you want to actually do some animation with it or show people how it works, you can go back and you can create the various bodies into components, but you've already drawn it in the correct position. So what you can do, you can apply an as-built joint to take advantage of that current position that the lid and the box are in. You can also set motion limits, use contact sets. All the things that were considered a little more advanced in, say, tools like Inventor are already in Fusion 360 as well. So let me just mock up a quick example of joints, and we'll then come back to the more conventional example. So what I'm going to do, back into Fusion here, and new design. So what I'm going to do, first of all, I'm just going to create a simple plate. on here. I'm not going to be bothered about too much size of it. I'm going to extrude it 10 millimeters, something like that. I'm not being too bothered about that. Now, what didn't I do? I didn't create a component at first, yeah, which is a little bit annoying, but what I will do, I'll do it proper like I should do. So what I'm going to do is just click on that and just delete it, delete, and delete that. So delete my timeline, right click, new component, just call this plate 1. Okay, so now when I start, draw my rectangle, there, extrude, up, say around about 10 millimeters. Yeah, they just want it to be a new body. Actually, I could have gone new component when I was actually in there, so yeah, I just did something. Now what I want to do now is make a second component that I'm going to attach to this. So I'm just going to create a new sketch. So what I'm going to do is try get another way. So sketch, 2-point rectangle. This time, let's do a rectangle. I'm just going to put on there. Extrude that upwards. But rather than join, if I go new component, make that 10 millimeters. There. Okay. So I've got now. I didn't actually put that as new component, so let's do that. Change from new body to doesn't give me an option there to create it as a new component. Let's just cancel that. Let's open it up. Have I got? So I should have 2 bodies. Got 1 body. Is that one? Component 2. It's put it underneath that one. Yeah, because I've got plate 1, and because I didn't create it there, it's put it in there. So maybe I can move this and move the level of it. There we go. So you can, as you can see there, I created that component, but I had it at the wrong level. I'd actually created it underneath this plate 1. So all I had to do was click and drag it to my top level, and it's now created it as a separate component, which I can, there you go. I can highlight there as point 2. Now, what you got to think, how would you fix these components in position? So say I wanted to, just highlight and activate the top level again, so we've got both of them. So I've got 2 plates, plate 1, plate 2. Thinking about Inventor, maybe I wanted to add mate or flush these faces, or mate these 2 faces, then I have to align or flush these 2 faces to get them lined up. What I can actually do in Fusion is in Assemble up at the top, I can actually do joint. Yep. Now, one of the things I need to do prior to using the joint is actually ground one of these components. Yeah, make sure that it's fixed in space. Otherwise, it doesn't know in 3 dimensions what's being located to what. My first plate, if I right-click on it, I've got a ground option. Click on the ground, you notice I get the little pin next to it. That means now that that is now fixed in space and I can't move it. This one I can pull around, this one I can't. So I've now moved that, moved it around. If I go to the joint tool, I'll just capture that position where this is at the minute. Now what you will notice as I hover over each one of these faces, I get different selection parts and different sort of options here. So if I wanted to have like a flush face, I could actually pick this point here or this side underneath here. So if I said I wanted that to be with that point there, automatically comes as a rigid fix. I've got my manipulators, so at this moment in time I can spin it, I can move it, as well as having the options to do this here. I can move this around. Yeah, I can even lift it off, so I can actually join something, but with a gap between it. I can do all that here. I could change the type, so if I went revolute, it asked me what axis do I want to actually revolve that around. But I'll just go in at the moment, going to do a rigid, and I'll just move it out and spin it around to there. Okay, and that's actually now joined together in that position. Yeah, it's now fixed. So how, if you compare it to Inventor and using constraints, the amount of time, ground again, Sam, I'll explain ground again. If I remove, let's unground this. So what happens now, I'm going to actually remove these joints as well. So let me just delete that joint. So at the minute now, I've got these objects. Let me just remove ground, unground that, continue. Right, so I've now got these two plates that I've drawn in a three-dimensional world, but at the minute they can both move relative to one another or independently. Nothing is actually fixed. So if I was to start to try to assemble these two components together, which one would move to which component? Would one move to the other, or would one stay still and the other one move to it, or would they both move towards each other? We've got no sort of reference to work to. So what grounding does, it actually fixes one of our components in its location and says, like, that's where it needs to be, that's where it's going to be fixed. So what I can do now is with this plate here, if I ground that, so I've right-clicked on it and pressed ground, and capture position, that's just where it is. Now, if I try and select it and move it, it doesn't move. This one does still, but that one doesn't. So I know now, once I start applying joints, this one is going to move to this one here. So I've got this physically fixed in this location. Again, assembly, join. I'm just going to capture this position here. Hovering over this edge there, if I was to click that one, which was like the rotate part there, and that edge part there, these are both located together on the midpoint. I can spin that round. I could change it to a revolute joint. As you can see, I'd have to put some, remove some degrees of freedom in there. And I just move that to 0. There, and then just move this out a little bit and across a little bit. I can very quickly put in some dimensions there to locate something solid, and then press OK. Now, one of the things we can do, this is if I'm building something, I'm not so sure exactly if it's going to work or whether the concept that I'm designing is going to work. We can actually do something called what's it called now? As-built joints. Sorry, as-built joints. Just to show this, I'm just going to quickly create a new component. So sketch, assembly. Let's try this. Assembly, new component on this top surface here. Component 3. Empty component, C parent wants to be top level. And circle into diameter on that top face. So if I was to position a circle, so something like this, start sketching, extrude that upwards. You see it's added another component in here, and then just to make this a bit clearer, what I'm going to do here is just draw another, let's do sketch, rectangle, zoom in. I'm just going to overlap that a little bit. If I then press pull that bit and just move that down a little bit. Okay. So what I've actually done now is I've just created another component on here, this, that I've got in position that I think might work. The only thing is, what I want to do is test it. So I've not put a hole in anything yet. This is just prototyping. What I'm going to do is now create assembly as built joint. The components, so select the one that's going to move first. Then that one. Position is that center there. And it's picked up a revolute joint there. Okay, so now what I've actually done is I've put an inbuilt joint. It recognized that it wanted to be a revolute, and I can actually should be able to pull this round. Which one's it picked up on? It's picked up on that one. Let's suppress that joint in a minute. Let's just pick up on this one. Press that. So this has now picked this joint, and what I can do is I can actually drive that joint. I can actually spin it round, and I can make sure here, whilst I'm doing this, that before I actually make any more modifications and changes to my plates, I'll start drilling holes in. I can see whether it works like I want it to work. So that's an as-built joint in there. Now, just before, I'm just going to quickly now look at a very quick exercise with these joints before we have a break. And so this data set that we'll be using now is a nice. I don't want to say that. You can end up with too many of these. Let me just get rid of some of these. Don't save. Let's get rid of that. I'll keep that one still. Come back in here. If we just go back one level and we go to assemblies and joints, hopefully that's the right folder. So this is a real nice one to use. There's some real nice joints in here. When it loads up, as you can see, we've got all our components. We can see there the one that has been grounded. So the gear housing itself has been grounded, so the green one. And what we've got here are some components. We've got the pin that's going to go in the center. We've got the gear that's going to go on the pin, and then finally the crankshaft and its bits and pieces are going to be in there. So I can go straight away to the joint tool command. So I could go up to assembly and joint, but you can see there J, there's a shortcut. So I just type J, go straight to the joint. We're going to select the bottom of the top section of this pin. But what you will notice here, I'm going to now select this pin here. You'll notice as I'm going up and start sliding that, I've got other points coming up there. This is actually a midpoint of this particular section. So where we've, in previous other softwares where you've got to create construction geometry, construction planes to be able to pick up things like that, actually in Fusion itself, you've actually got these extra little bits to help you. It's like there. So if I wanted to do a midpoint sort of joint, I could do there. With this one, I just want to select this center there, so that bit. And what I want to do is I want to join it to the top there, so if I select that. Now you'll notice it's picked up my original, my last command that I used. So the last one that I did was the revolute. And I think for this particular, that's all right to actually use here. It will pick up the bottom there, and we just want a revolute. Is the last one. It animates it a little bit. We can press animate and it shows it in there. If I press OK, that's now moved and it's in position. And it's the exact point where I want it. Now, what I next want to do here is put this onto this. Now, again, J for joint. as I hover over this, you'll notice that it can get quite difficult to select exactly what I want. But a little hint: if you hover over the face of something, so this face here, and I want to pick up a point, if I hold the Control key down, you'll notice no matter where I move my cursor now, it just leaves up this selection set at the top. Or if you're using a Mac, it's the Command key. I can isolate my selection to be the only point on the face. So I'll select the center of the hole now, clicking that. I can then go to the pin. So I'll go to the top of the pin, and I'll select the top of the pin. And you'll notice there what it's actually done. It's actually spun it round. So what I want to do is flip. So to flip it around the other way. So you've got a flip option there. And rather being revolute now, I want this to be a tight fit. And if watch what happens to these when I click rigid. It shakes. So it's a rigid joint. But also what I want to do is I want to actually this to be a push fit, and I want it to be 3 millimeters lower down. So if I start dragging it down, again, I've got the dialog box that comes up, or also in here, I can just type 3 millimeters and OK. So I've now OK'd these two things together. Now where geometry can be a bit more challenging, I've just showed how you can isolate the selection set. So using the Control key. What about where there is no geometry for you to select? If we look at the front end of this crankshaft, so let's see if I can spin this round here. So the crankshaft here, the arm itself, let's move it down. Ideally, what I want to do when I'm joining this part is I'd want the midpoint between that face and that face. Sorry, the underside face there. I'd want it to line up with the mid face of the midpoint or the work plane of that face, and wherever it's gone again, that face there. So I'd want it to align midpoint to midpoint there. And as you can see, that I don't think there's much that we can actually select there. Now, what I'm going to do is show you a way that we can actually select between two faces. And the way that I'm going to do that, we're going to start the joint tool. So J, joint tool. So I'm just making sure I get this in the right order for everybody. And if we start the joint tool and then right click, there is actually a between two faces option. So I'll just show you that again. We've started the joint tool. We're hovering off so we're not actually selecting anything at the minute. If we right click, we've got between two faces option there. Yep. Now you notice when I deselected it then, so if I select it again, this allows me then to select the first face. Then let's see if I can get under to the second face there. So I've now selected that. Oops, let's see if I can get around it somewhere. So there you can see now we've got this, and then we can select, and then hopefully in the second component again, if we can do between faces, between two faces, between that face and, well, we could do between two faces, but actually what we can do on this, on component 2, if I remove that between two faces option, I've just come out of that, sorry. Hey, let's go back into it, right. So escape, joint tool, let's do this again now. Component 1, right click, between two faces, for that face, and let's see if I can spin this around a little bit. Let's do it this way. And that face. So now we can actually, you can see there, we can select that point I think we've got. Yeah, you can see where it's selected it, that midpoint. With the second component, what I'm going to do is, if you remember here, we've actually got a cylinder going down, and we can actually just move down to that midpoint there. Now that's rigid. We don't want rigid, we want a revolute. You can see that's now got it in position as we want it. So it took a bit of doing that, but we got there in the end, and it showed you another option, and then we can press OK. So we've now leveled that up, and you'll notice that the bushes come with it as we've done it. And then finally, what we can do, we need to actually line up this with this. Now, if they don't line up, if there might be some sort of gap between the top of this boss and the underside of this face here. So what we can do, the joint that we can use for this, we just use joints, and I want that one and that there. If we actually, rather than using a revolute, use a cylindrical joint, which means it can go up and down in that direction. If we then press OK, now what it's done, there's something that's not been fixed at this end. Just hold on. Let's move this around here. What we've actually got here is this that's not been fixed in position. That's why it all moved then. So what I need to do with this is in Assemble, As Built, that component and that component. Position is that one. It wants to be a slider. So like that move, there we go. That's better, that's now fixed in there. So now that we've done that, let's just see whether we can go J up, catch position. Let's click that one and that one. Press OK, and there we go. So we've now actually located that, and we've got that now in position. If we rotate that, you'll see that it will actually rotate. Now, one of the things we can do, we can actually animate this a little bit from this. If we go into the joints and we look at the first Revolute one that we did, which was the very first one, right click and is it animate model, animate joint? That's just the animate joint. Sorry, stop that one. Let's get from that. Right click, animate model. There we go, sorry, animate model. It's just picking the right joint from the top there. So you can actually animate your model and see how it works. And which is great. And then it'll just keep animating and moving until we've done. And that's it, it'll basically run until you stop it. So to stop it, I just have to press escape. It stops. We can also select any joint and set joint limits and set a pause position using the reset option. So in here, you know, there's lots of bits and pieces that you can do. So you can edit the limits that it moves to. You can lock it. You can actually, you know, drive the joints